I accidentally did 16 and I was very confused what they meant because you could take multiple different things at a time.
I'll have to look at 16 and see what that's all about.
12? Yes, I did.
My regular class, they could not do number 10.
Number 10.
And I knew that every year, that's why I had that thing on the slide. Every year, people like, I don't know what to do.
You have to use Pythagorean triples.
What?
That's what I did.
Not on
That's
10.
what I did Pythagorean triples for.
They may be triples, but I'm saying you didn't have to. They didn't have to be a triple to get to an answer.
Hello.
What's up, Ben? Welcome back.
The opposite of down.
You okay? How come you weren't here yesterday?
I thought that I explained this in the assignment I sent you.
I only read those on Saturdays.
I looked at the thing, the homework, and I saw it was due today, and I'm like, oh, since the homework is due whenever we do the Zoom, that means we must be doing starting Zoom today, and I didn't realize that I was wrong.
It's okay. All right, questions?
9 and 10.
What did I tell you? What did I do? Well, you missed the class.
I watched the video, so.
Yeah, but I drew it on the board and used my hands to illustrate it, so you didn't see that. Here's the basic idea. I'll just do number 10 for you real quick. You got two triangles.
Oh, I want number 9, then 10.
All right, I'll do number 9. I'm flipping pages here. All right, on number 9, do you see the green triangle?
Yes.
That one is a right triangle. How come?
Yeah, because angle UTS is a right angle.
Yeah.
Therefore, it's a right triangle.
I got a hypotenuse of 13. One leg is 12. That one is a Pythagorean. I see what Jack was saying. That one is a
both
Pythagorean triple. No, I'm saying 9 and 10. So 9. So that would give me on the green one, the other side ends up being 5. Do you understand why it's 5?
Yeah, I understand why it's 5.
Okay.
Also, because of the
yeah. So now we have the yellow or orange, whatever color that is. Yellow triangle. It has sides 3, 4, 5. Now maybe you realize that was Pythagorean triple. Maybe you didn't. But it basically shows it. It says prove that it's or show that it's a right triangle. The only way you show it's a right triangle is if a squared plus b squared equals c squared. And we learned in class the longest side, if it's a right triangle, is always the hypotenuse. Therefore, we just figured out that ST was 5. 5's got to be the hypotenuse. So if you throw that into Pythagorean theorem, you find out that 3 squared plus 4 squared does in fact equal 5 squared. Therefore, you just did it. Number 10 is done exactly the same way. It's just the orientation is a little bit different. This time you're trying to prove it's obtuse. So you got to prove that c squared is bigger than the square of the sum of the other two sides. But it's done literally exactly the same way. Take the yellow triangle, find out the third side. Now you have the 3 sides of the blue triangle. Now just do Pythagorean theorem. You find out the c squared is, or in fact, c squared is BD. Is larger than the square of the sum of the other two sides. Did that make sense, Ben? I said that pretty fast.
Yeah, that kind of makes sense.
Anybody else? All right. Number 1 is acute. Number 2 is obtuse. Number 3 is right. Number 4 is right. Number 5 is obtuse. And number 6 is right. And everything in 7 and 8, A and B, are all right. Apparently they had a broken computer or something. They just wanted to write the word right a lot. So I just explained 9 and 10. 11 is acute. 12 is obtuse. 13 is obtuse. And 14 is right.
You're supposed to do 15.
Yeah.
You got 15.
So it turns out that X would have to be between 12 and 16, not including 12, but including 16. If the longest side was 20. All right. Then we have 19. Where's the answer? Oh, 19A. If the square of the longest side of the triangle is greater than the square of the sums of the other two sides, and the triangle must be of two. They're just asking you to rewrite that statement of 8.5. B is doing a proof. I'll look at your proofs. That's why I gave you 19, because it's a proof. All right. All right. Today is I'm a broken record. I'm always going to say this. No, really, today is a pretty big day. Pretty big day. Pretty big. Don't read ahead. Spoil it.
I already did, sorry.
All right. If, unlike me when I was in high school, if you can, I had it memorized by senior year, but I certainly didn't memorize it in sophomore year when I took geometry. If I had memorized it in sophomore year, it would have made algebra 2 and trigonometry and pre-calc a whole lot easier. But I didn't memorize it. We were supposed to have a quiz today. I blew up the quiz. Tomorrow, we're going to review everything we've done so far in 8.4 before we get to the trig, which is 8.5 and 8.6, so that we make sure that we haven't forgotten everything. So we'll just do the three things. Those two corollaries, we'll just do a practice worksheet. Then the Pythagorean theorem work, and then what we did last night, which was, my mind is like, how can you tell whether a triangle is right, obtuse, or acute? Okay. All right, here's your homework.
It's a lot of homework.
This will involve an ability to take a shape, twist it and turn it in your head, and apply it to another shape. So for some of you that are good at that, this is going to be really easy. For those of you that can't think through them, you need to draw this out. Or at least have the basic shape drawn in front of you so that you can manipulate it with your hands to make it look like the question in the book. Pretty quick class. We'll do the classroom exercises if we get a chance, and you should have pretty good. Remember I said this book loves its tables? Period 2, the non-honors class, they were utterly confused by the table, and then we did a couple problems and they're like, oh, okay, now we get it. So I don't know if you guys will be confused by the table, so maybe we'll do some of those as well too. That's questions 1 through 16 all involve a table. All right, special right triangles. Big, huge, confusing if you don't pay attention. You guys pay attention. You will see special right triangles, maybe not in so much in algebra 2, maybe a little bit, but certainly pre-calculus, calculus, a higher, you see special right triangles all the time. And so this is something you memorize on equal, on par with the Pythagorean theorem, special right triangles. Luckily, you have my class, so it's going to be in your book of truth. You take me for pre-calculus, then you'll be on a resource card. But you get to college and you're in a calculus class, you know, they expect you to know, hey, what's the side length when it's a special right triangle, like right off the top of your head, okay? All right, here we go. Think about this. We have a right triangle. How big is angle C?
90.
Okay. Well, how big is A and B?
The sum that equals 90.
Okay, I'll buy that. All right. Right, pretty easy. Well, deep subject. Well, if that's true, how many right triangles can you make?
Yeah. So many.
How many?
Beyond many. Infinite amount of right
Okay.
triangles.
So if you have an infinite amount of triangles, why do we have special right triangles?
Because
You've already
because-
cheated.
because
What? If there's an infinite number, why are some of them called special?
Because some idiot came up with it a few years back and was like, yeah, this is how things are now. And then everybody's like, sure, idiot.
So who gets to be special? Like if
Rich
there's
people?
a class of 20 kids, who gets to be special?
Jack.
Why?
Because he's Jack. That's
Okay.
why.
Well, I mean, for me, this is the question of why do these two triangles get to be called special and the rest of them are just non-special, okay? I don't have a good answer to that, but I'll try to explain why I think they call them special. All right, so special right triangles, there are only two of them, right? Obviously, they're right triangles. The first one is called, take a guess.
45, 45, 90. Right?
That also would make it a isosceles. I get that one. This one, to me, in my mind, yeah, that one's special. Also, If you double this shape, guess what you get? You double this shape, guess what you get?
What?
You double this shape, guess what you get?
You want me to answer?
You can answer this one because it's not in the book.
All right, 30, 60 right triangle? I don't know.
No.
I know what the next
If you
one is.
double that shape and put the shapes together, what do you get? You get a square,
Yeah.
right? So maybe that's why it's special, is because it makes a square, right? It's half of a square. Yeah, it makes a square. That's cool. It's also isosceles. I'll buy that. This one is special. The second one, oh, there's our square. There's half of it right there. The second one is called something else. You can't say. There are two other numbers that when you add up, you get to 90 that I guess in some sense are special. What are the two numbers, if you add together, you get to 90 that would maybe be special?
90 divided by something, whatever that number is. 3 times 16.
3 and 87?
Yeah,
That doesn't sound very special.
that sounds special. But it's weird. You don't do that.
10 and 80, does that sound special?
Yeah, no.
All right, well, then what's the other two numbers?
4 and 5.
4 and 5 doesn't add up to 90.
But if you times it, you get closer to that.
40 and 50? Not very special.
Oh, a square root of 16 plus something.
All right,
Let's see this.
go ahead, Jack.
30, 60 right triangle.
So I don't know why they think this one's a special.
That's special.
But if you notice that, okay, half of 60 is 30 and 30 plus 60 is 90, maybe that's why they call it special.
That's not special. That's just
Right.
a normal right triangle. There is nothing special about
I agree.
that
This one I don't feel is very special. However, if you double this one, you do get a special shape.
Oh, you get a,
You do not get a, well, okay,
you get more of like this shape.
but you don't get a special rectangle,
Oh, you
right?
get like a,
If you double that shape and place the pieces parts differently, you get something other than a rectangle.
you get a
kite.
No,
you get a bigger triangle.
no.
Yeah,
You do get a bigger triangle. What kind of triangle?
I'll prove that you
Isosceles
get a triangle.
triangle.
No.
A hexagon triangle.
You get an isosceles triangle.
No.
Yes.
That's what I
No.
said, Jack.
Yes.
Yes.
Technically, I would argue no.
And an obtuse triangle.
Absolutely not.
Yes.
30 and 30 is 60, not over 90.
Put 60 and 60 together and you
But then
make
that doesn't make a triangle.
Yes, it does. It makes an opposite. Okay, I'll prove this to you. I'll
It
prove
doesn't
this like
make
a
a
theorem.
triangle. It makes a quadrilateral.
No, it does not.
How about we put one next to each other on that side?
That's what that's an isosceles triangle.
That's not an isosceles triangle.
Yes, it is.
I'm going to argue it's not, but simply by the definition of isosceles. What's isosceles say?
That the two sides are the same.
I'm going to argue that the three sides are the same.
Make an equilateral.
It makes an equilateral triangle.
It's still an isosceles triangle though.
No, so that's why I was going to say I'm going to make the argument because the definition says exactly two sides, not at least two sides.
Okay, but it does make an obtuse triangle if you put it together in the right way.
No.
Yes, it does.
I don't think you could put them together.
Yes, it
in
does.
a way.
All right.
I will prove
Let's
it.
get this class over and then we'll explore that one. Okay, so if you put a 45, 45, 90, you get a square. If you put a 30, 60, 90 together, you get an equilateral triangle where the altitude is the two long legs, right?
This is not special.
30 plus 30 is 60, 60, 60, 60, you get equilateral triangle, okay? All right. So those are our two special right triangles. And yes, I'm not joking when I say you're going to use this over and over and over again. They're going to say, hey, special right triangle. How long is the hypotenuse? How long is the side? And you're expected to know the answer without using Pythagorean theorem, right? All right. So the first thing we're going to do is we're going to prove something about a 45, 45, 90. Guess what we're going to try to prove?
That is.
What's it
equal
say?
to C.
What's it
C
say?
equals 8.
What's C?
C is a side.
So the hypotenuse is equal to
One leg times the
leg.
square root of 2.
one leg, and by the way, both legs are exactly the same because it's isosceles.
So it's a to
The
the
leg root 2. In other words, if you want to find how long the hypotenuse is, you don't need to use the Pythagorean theorem. You just take the leg and multiply it by the square root 2, and you're done.
With Pythagorean theorem,
Not
it's
that
easier.
What?
It is kind of easy, but I mean, if you're trying to get a number answer, it's not easy.
Oh, okay. Well,
You're going to find out that this for the 45, 49 is a nice one.
I
The
mean, it
3069 is not
All
nice,
right,
but this
so
one's
You're
pretty
trying
nice.
to multiply by the square root of 2, and you're trying to get a numerical answer.
All right, well, first off, let's prove
Not
this
a
is
radical
true.
answer.
Well, if it's
Okay.
if 45 plus 45 equals 90, then you can divide that by 3, and then you get all the numbers for those sides. That
No, we're not gonna do that
But you
Right.
can do that.
and get the wrong answer.
No, but that's still the right
McKinley,
answer.
McKinley.
It's the right
All right.
answer.
Let's have the smart McKinley show up every day, not the smart Alec
I'm
McKinley.
not being that. I'm telling you,
All right.
that thing.
Here's how it's proven. All right, what we're gonna start is with, well, it's a right triangle. What do we got about right triangles?
A squared plus B squared.
We got a squared plus b squared equals c squared. So we're gonna start off with that.
2A
But
squared,
notice I didn't write a squared plus b squared. Why not?
2A squared.
Because it's isosceles, so therefore the legs are exactly the same. But what's a squared plus a squared? Okay.
And then you can do
And
the.
then what's the
square-
square root of 2a squared?
Is 2 times the
2A.
square, no, 2A. No, square root of 2 times A.
Yeah, we're done. That was not a very hard proof. Right? But I want you to think of what we're saying. We're saying, hey, forget about that. This comes from the Pythagorean theorem, but forget about it. The hypotenuse is equal to the leg times root 2. And if you further, some books do this. Some books will say, well, now I can prove what A is equal to. What's A equal to?
Is 2C.
Close, but no.
2A.
Just solve for A.
Square root of 2C.
Get A by itself.
Oh, C over root 2.
Except we can't have a root 2 in the bottom, so we need to
Multiply both.
by
4.
root 2, which would give me A is equal to C root 2 over 2. Some books will have that. Our book chooses not to say that. But I can now have a formula that doesn't use the Pythagorean theorem, that all I need now is, well, I still need one side. Pythagorean theorem, you always need 2 sides to solve for the third. Now I only need, but it's got to be a 45, 45, 90. I only need one side. I either need A or I need the hypotenuse, and I can figure out what the other side is. That's why this theorem is pretty important, because now you're going to be able to figure out if it's a 45, 45, 90, you can figure out something about the side pretty easy. So this is 8-6, and it basically says this. Now, this picture is not in the book for me. You see the bottom here? This is what's in the book. This is the more useful one. I mean, this tells you everything you need to know. You got a 45, 45, 90. The legs are A, and the hypotenuse is A root 2.
Wait, I thought this was okay.
Now, I made that one up right there, but I find that way more useful. This one right here in the bottom. You flip to page, I don't know, 300, you'll see Theorem 8-6, they don't have that picture. They just give you a right triangle, a 45, 45, 90 that says A, and C. Now I'm going to break from all math books and all math teachers. I'm writing mine like this. Do you know how the book writes it?
C equals.
They write theirs, I don't know why, it's never been explained to me. They write theirs as the square root of 2
Times A.
times A. The issue with that is if you're sloppy, you think the square root symbol goes over the A and it doesn't. So I'm going to always, whenever I've taught this, I choose to write it this way. But I will warn you, I have a slide here in a second. Every math book I've ever seen writes it the other way. They write it's C is equal to square root of 2 times A. But even saying that, you could easily interpret it as the square root of 2 with an A underneath of it. It's not. So if you look at page 300, they say square root of 2 times the leg. I don't like that. We okay on this one? This one's the easy one. Okay. So once again, this is what I was trying to point out, is that the book will write it something like this. They'll put if the sides are K, they'll put the K on that side instead of the other side. Most math books that I've seen write it with an X, not an A, not a K. They write it with an X. So they'll say square root of 2 times X. Put the X on the other side, so you don't make a silly mistake. You still get the same answer. All right. So here's how it works. They're going to give you tonight for homework special right triangle. Well, it's 45, 45, 90. They're going to flip it, turn it, twist it, and they're going to give you a couple sides, probably a couple variables. What you need to do is take what you just wrote down and either flip this sucker or flip this sucker so it matches up, and tell me which pieces match up. Can you do that in your head, McKinley?
Yeah,
A would match what?
it would match 12. No, wait. Yes, 12.
And X would match.
A squared 2.
If you can do that in your head, then life is good because you can solve for it.
Or you could just say.
We know from the previous theorem that C is equal to A root 2.
So
You just told me that A matches with
12.
So then all I got to do, if I want to find out what C is, which is X, toss the 12 there and I'm done. And Jack was going to say, wait, all you need to do is put the, yeah, that's it.
Yeah, also, you don't really need to flip it around in your head. You can just see that it's off to the right angle, it's off the hypotenuse.
I'm just going to say some people need to flip this around in their head, right? I will literally put this question on a test, and I'll have someone that says that this side matches that side. So be careful. I've not talked about exact and approximate. Okay, so I'm going to choose now to talk about it.
That's exact.
This is called the exact answer because
Because it is exact.
it's got an equal sign.
So then you can say X.
Square root of 2 is not able to give you an exact answer. I can tell you what the square root of 2 is approximately. Square root of 2 is approximately 1.620
probably.
1/8, right?
No, bigger than that.
Wait.
Do the square root of 2.
1/4, yeah.
1.4, right? And a whole bunch of decimals, right? Okay. So if you leave it as the square root of 2, it's called the exact answer. If the book ever asks for the approximate answer, they're asking you to multiply 12 times the square root of 2, which is, in this case, is approximately 16.97.
That's it. How do you multiply 12 times the square root?
Where's your calculator?
Oh, I forgot. I have that thing somewhere.
Remember, multiplication is commutative. For me, since the square root of 2 is always the hardest thing to type in, I do the square root of 2 first and then multiply by 12. It can be done either way.
Wait.
On the graphing calculator, though, it's very easy to do. You literally type in 12, multiplication symbol, blue button, left side, 5 or 6 buttons down.
You don't need to do the multiplication symbol.
You're right. It does equal.
You don't.
Just do 12 root 2.
But I do want you to remember it is multiplication because if you're grabbing some other regular calculator, you need to remember it's multiplication.
It is.
On our graphing calculators, this TI-84, it understands that 12 root 2 is 12 times root 2. So it's pretty nice that way. Okay, we good? All right. Once again, they're going to twist it, turn it, flip it. What you need to do is match up pieces parts. Allie, what does 8 match up with? Okay, what does X match up with? Okay, you take those 2 bits of information with the theorem. I forget the number. What was the number? 8. 8.6. This is 8.6 for 45, 45, 90. C is equal to A root 2. And then you plug in what you want. It says solve for X. X was what?
A.
So I'm going to make AX. I'm going to make C. And then solve for X.
Divide 2.
Divide by
Square root of 2.
Well,
Both sides, square root of 2, right?
So it's, yeah, you can also just use the exact same thing. A root 2 over 2.
But we can't have the square root of 2. Both sides, or top and bottom by,
Root square root.
which gives me,
A root 2 over 2.
which reduces to, no,
4 root 2.
Yeah.
there you go. Yes? Ben, yes?
Oh no, Ben disappeared again.
Yes,
Yeah.
sorry.
Okay. So that's the exact, and now that you have your calculators out, the approximate answer is?
Oh, okay. Cool.
Did you charge your calculator, Jack?
5.656854.
What is it?
5.6568.
2 decimal places.
5.6.
5.6.
2 decimal places.
5.66.
Have I shown you how
No,
to
it's
get,
5.65.
6. 5.656.
have I shown you how to get your calculator around for you?
Yeah, just go to mode and then go to float and then go over to 2.
You got it. Nikila, you remember that?
5.66.
Oh, okay.
Be careful with that because if you leave it on that, you'll forget. But if the question, you have a calculator test and it says, round to the nearest hundredth, then heck yeah, let your calculator do the work for you. Less chance of making a mistake.
What can I do with these functions?
Oh boy, you're going to find out next year in Algebra 2. All right. So 45, 45, 90 is the easy one. It's the 30, 60, 90. It's not that much more complicated. And then, like I said, the bigger picture is if you can memorize this right now, you're going to be so far ahead of the game. The problem is that we only do it this one chapter. We don't. You get to pre-calc, you use it, I'm not going to say every day, but you use it all the time. And so it's a little bit, you will be forced to memorize it then. All right, 30, 60, 90. Now, a 30, 60, 90, one of the legs is longer than the other one. Which one is always longer?
The
The one that is opposite the 60.
Yeah.
Okay, the one that's opposite the 30 is your short leg. The one that's opposite the 60 is called your long leg. Obviously, that's still called the hypotenuse. So we're going to use these very technical words, short leg and long leg. We're going to use this in our formula, believe it or not.
Why is short leg A and long leg B?
Well, remember, if you have a right triangle with legs A, B, and C,
Yeah, but why is short leg A and long leg B?
and that's why I'm saying we're not going to worry about it's called A or B. We're going to say short leg, long leg. Okay. All right. So this is probably the longest proof of the year so far.
Oh, brother.
And that's only because they want us to prove two things here. They want us to prove two different relationships, that the hypotenuse, C, is double the short leg. Okay, that's kind of remarkable. And that the long leg is equal to the short leg times the square root of 3.
Oh,
Okay. All right.
double.
This is pretty cool proof. Not as beautiful as one yesterday, but it's pretty cool. And because there's two things is why it's so long. Each individual one isn't that long. All right. So I will first prove that C is equal to double the short. If you double whatever A is, you got the hypotenuse. That's pretty cool.
That's nice.
All right. So how are we going to start this? We're going to start off this by doing one of these constructions. So here's the construction. Look at the board. I'm going to extend BC over here to the right. And I'm going to put a new point D. And CD is going to be as long as BC. In other words, I'm making another A. See what I did?
Yeah.
And then I'm going to connect D to A. So now I got two triangles next to each other. Hint, hint, hint. We've already talked about this construction.
Well, it's an equilateral triangle.
It's an equilateral triangle. Right? Black triangle, red triangle. Are they congruent or not congruent?
They are congruent.
Why?
Because it's an equilateral triangle.
Oh, no, you got to go further than that.
I say
And where did you get your two sides from?
A,
Okay, that we made A the same as A and
B,
and
reflex.
reflexive
Yeah.
and the 90 degrees. Okay, so all of that, there we go. So I just showed that now that this, since they're congruent to each other, that if this is 30, this is 30, if this is 60, this is 60, therefore it's an equilateral triangle, because by CP/CTC that, therefore it's got to be equilateral triangle by the definition of equilateral triangle. Okay, equilateral triangle. So what? We need to get that C is equal to 2 times A.
C is equal to 2 times A. If it's an equilateral triangle and C is the midpoint between it's BD, then BC times 2 equals C. So then C divided by 2 equals.
Well, you're saying way too many things at once. Give me your first one.
Okay, my first thing.
If it's an equilateral triangle,
if it's an
then
equilateral triangle, then C equals 2A.
C equals 2A.
Then you can divide by. Then
You're done.
You're already there.
How is that a long proof?
No, that's we're only halfway.
We're
We're gonna
only
prove the other one.
Well, you know,
I like yours better than the way the book did theirs. In the book,
whoa, that's a bold claim.
well, I mean, the only thing the book is doing is they're just breaking it up. He just, with one statement, said that since it's equilateral, they have to be the same thing, and since it's the midpoint. So you might argue that this is literally exactly the same. It is kind of, sort of, but it's basically that idea. Okay, so good. We're halfway there. The next one is kind of, well, you're not going to get the next one.
Oh, maybe No, I don't think I will.
Okay, well, they start off with Pythagorean theorem, right? So they're going to start off with black triangle, a squared plus b squared equals c squared, right?
Okay.
But wait a minute. You won't know why, but you'll know here in a second. I'm going to solve for b squared. Because b is the
Altitude.
long leg. So I need to solve for b, right? I want my equation to say long leg is b. So I'm going to solve this now for b. So what's the first step?
So b squared equals c squared minus a squared.
But wait a minute. I can say something about c squared from the previous statement.
C squared equals 2 times the short leg.
Okay. Yeah?
Yeah, and then you can do minus.
Now
a
let's square
squared.
it.
So 4a squared minus a squared.
Oh,
minus 3a.
stop that. Don't let it catch up. So if I square that, I get 4a squared. I had to notice how small I'm writing. And 4a squared minus a squared is,
3a squared. And you can square root it.
and then I'm going to take the square root of everything. And that's where the square root of 3 comes from, and you're done. Notice the font got smaller and smaller and smaller as I went because I didn't give myself enough space. All right, that's a pretty slick proof. But basically it tells us these two statements, which is your next theorem. I mean, some books write it as two separate theorems, but we'll write it as one. Okay, so this is 8-7, and it says those two basic statements right there. I like this triangle better because it puts the formulas where they need to go. The short leg is equal to a, the medium leg is equal to a root 3, and the hypotenuse is double a. And if there's one that gives you problems, conniptions, it's this one because there's just a lot of stuff going on there.
Now I know how to do this.
But there's always special things with something. I mean, like root 2, you can always say like this is equal to 6 root 3.
The way that I remembered it or memorized it was, I knew there was a root 2, I knew there was a double, and I knew there was a root 3. And not one of them had both roots. So this was easy because this is a 30, starts with a 3, 30, 60, 90. So I knew that this proof had the square root of 3 in it. That means the other one had to have, or the other theorem, not proof, the other theorem had to have the square root of 2 in it.
And it couldn't have been 2 times a because it's an isosceles triangle.
Because it's an isosceles triangle.
Is there anything special with the square root of something?
Square root of the square root of 64 is,
2.28.
no, that doesn't work. The square root of the square root of,
81.
nope.
Yeah,
No.
81 you get.
Oh, yes, 3. Yeah, there we go. There's a good one. Okay, cool. Now let's do what we did before. I'm going to give you a picture. You got to think back to that. You got to do flip flop, flip flop, flip flop.
Aha. So
Ben, A goes with what number?
A would go with 6.
Okay. McKinley, X goes with,
X goes with 2a.
and that would leave Y goes with 3A. So it says to solve for X and Y.
No, it doesn't go with 3a. A root 3.
What did I say?
You said 3a.
Sorry.
3a. Oh, math mistake.
Oh, I'm going to claim formatting error.
That is a formatting error.
Formatting error.
I don't think any of us.
So
I should have like 5 points this year. You know how many times I
Ben
play on the
said that
game?
A goes with 6. McKinley said that X goes with 2A. And then lastly, I jacked it up and said that Y went with 3A, but in fact it's A root 3. Okay. Notice if A is equal to 6, I can immediately, X is 12, and we're done for X. Okay. Y, I eventually said that Y is equal to A root 3,
Right?
but A is,
6.
and we're done. That wasn't hard at all.
Yay.
Okay.
Which means that math is mine.
All right. The numbers can get really ugly really quick. Watch this one. Okay.
Oh, oh.
All right. A goes with.
Oh,
See what I mean? So A goes with X.
Y goes.
X goes with A. Y goes with
2A.
2A, and 8 goes with. Doesn't matter how you set this up, but eventually you have to deal with all three of those. So some people say, oh, there's a solid number here. Let's start with a solid number. That's fine. You can start with that A. You can start with whatever you want to start with. So I'm going to start with that 8 with the whole number. You told me that that is the long leg, so A root 3.
You get the same thing no matter what you do.
You do, exactly. It doesn't matter where you start. Okay. Further, you said that X, short leg, is equal to A. It says we're supposed to solve for X. So A is equal to
X.
and then I'm going to solve for X. Same drill.
Divide by 3, multiply.
Divide by square root of 3, and then multiply everything.
So 8 root 3 over 3.
Not a, I don't know, enjoyable answer, but it is an answer.
But you have to, no, you don't have to. Do you have to put that back in? No, you have to.
No, because it says solve for X, and we did. Okay.
And multiply by 3.
For Y, what's Y equal to?
2A.
Nope, never mind.
Okay, Y is equal to 2A, but we know what A is equal to.
8 root 3 over 3.
Well, A is equal to X, and X is equal to 8 root 3 over 3, so I have to.
Put that in.
Distribute it properly. So you get 16 root 3 over 6.
Over not 6.
Not 8. Is what? 16 root 3 over 6.
I don't like this.
We're not multiplied by 2 over 2. Multiplied by just 2
over
Oh.
3.
over 3. Okay. Ben, you tracking on this?
Yes.
Okay. So like I said, you're gonna, especially tonight for homework, review tomorrow, you're gonna get these they're just not friendly answers. Special right triangles, typically, especially the 30, 60, 90, they're all about this stuff.
Wait, though, because if you multiply by 2 over 2, that means you're multiplying.
Double it. That two multiplying by 2 just means add 2 of them together.
Yeah, but if it's 16 root 3 over 6, we don't know that that's the same. as
Where are
8
you
root
getting
3.
a 6 from?
I'm saying if we're multiplying it by 2 over 2, then it's 1. And then we can't really.
Well, if you're multiplying by 2 over 2, you're just making an equivalent fraction.
Right, but how do we know? Because it says 16 root 3 over 3.
I'm not multiplying by 2 over 2. I'm multiplying by 2. I was just saying the only way you're getting 6 if it was 2 over 2.
I know, that's what I'm saying.
Well, we're not doing that, though. We're just doubling it. Okay, cool. Remember, we're going to use, just so you, I mean, obviously, if you see a 45, 45, 90, you're going to use the formula. But I also want you to remember, if you see a square, the diagonal of that square, right, is the hypotenuse of a 45, 45, 90 triangle. In other words, this diagonal right here is equal to the leg times root 2. So, or a side of the square
So you can use that same.
times root 2. And you can use this from now on, right? If it ever says how long is the diagonal of a square, you can just say it's the, the side of the square times the square root 2. And I mean, that works always. And that is a little bit of a time saver. Okay. 30, 60, 90 makes an equilateral triangle, or I shouldn't say makes, but it is 2 of them put together as an equilateral triangle. If we think about our 2 formulas right here, remember B is the longer leg or the altitude, and A is the shorter leg, and C is the hypotenuse. Okay? Cool. All right, let's look at some of these examples. Pick one, McKinley. Pick a hard one.
7.
Let's look at number 7. Clearly, we have a
Right triangle.
true.
That's
That's not what I was looking for, but yes.
a square.
We got a square. We are told that the
Well, do we know that though?
diagonal is,
8.
and we said from the previous slide that the diagonal, which is C, is equal to A root 3, right? Where A is the, sorry, A is the leg. In this case, the leg is, okay, and we know that C is
8.
So could you solve that for x?
Yes.
Heck yeah.
It's 8√3/3.
And you already know how this story goes, right? There you go.
Wait, isn't it C equals A√2?
Good God, that's a point.
What?
That's not a format. That's a point. All right, I'm starting with an I this year.
And with an extra L.
No, you gave extra L because it doesn't sound right.
I feel like I've definitely gotten a point this year.
You got the point. All right,
Well, he's never used it.
I've never gotten it on the board.
pick a hard one.
Honestly, I feel like we've
Pick a hard one.
gotten point before now.
A 9.
Oh, by the way, that can be reduced because when you do the square root of 2 over square root of 2, it turns into an 8 over 2, so it's 4√2. Right. Okay. Number 9, you think's hard? Not a shaped root, it's quadrilateral of some sort. But we have a combination of
2 of them.
2 of them. So we got to solve for x. X is a leg of 45, 45, 90. And we know that a leg, well, we don't have a formula for that, but we do have that C, let me get it right this time, is equal to A√2. Do we know the hypotenuse? No. Do we know a leg? Sure, it's x. Now let's focus on the 30, 60, 90.
So we do 9√3 over.
Long leg, short leg, what?
That's the long leg.
All right, look at your book. Make sure you don't screw this up.
it's
So
that times
long leg is equal to, well, we said B is
Short
equal
leg.
to what?
Oh,
short leg times
so-
√3.
So short leg, which is unknown,
So we just say
we can do that. A times,
times √3.
Mhm.
And then,
that didn't really get us. We got 2 variables. That didn't help us out. How about we say the hypotenuse?
so A is 9.
The hypotenuse is called, well, it's called the hypotenuse. So C for 30, 60, 90 is equal to
18.
2A.
18.
Say again?
18.
Where are you getting 18 from?
Because it has to be
A has to
multiplied
be
times
9.
√3, so it has to be 9. So you have to multiply by 2 and then get 18, and then you get the
All right, slow down. Tell me what to write.
I already know what the answer is.
So tell me what to write to solve this one. We're stuck on C is equal to x√2.
All right, so then B is equal to A√3, but B equals 9√3, so then you divide by like √3, so then you can.
All right. I like that. 9√3.
Then you can divide by √3, simplify the √3.
So A is equal to 9, and my A's and 9's all
and then
look
you
alike.
get 6, and you get 18 for C.
So we know that the hypotenuse is double A, which we just said was
9.
9√2 over 2.
Wait.
yes,
Yeah.
because they share a hypotenuse. So
9√2 over 2.
why does he say 9 and not 18?
18
No, hold on.
Oh yeah, it is. No, it's 9√2.
Yeah, that's fine.
Because you would get a 2 on the bottom, and that would reduce the 18 to a 9. McKinley, did you follow all that?
Yes.
Okay. So this one was the hardest one. That was pretty good. Now I'll open up your books. Let's look at that table before the bell rings.
Can I show you why it's a triangle as well?
Say again.
I'll show you why it's in a.
I like your idea that it was a kite before, not the triangle.
It was
But
a kite, and it's also a Swiss triangle.
I'm going with kite, not.
I don't think it's
both.
possible for that to be.
We gotta look at the table first.
Somebody give me a protractor.
What page is it?
302.
We're almost halfway through the book.
Okay.
All right. Pick one.
8.
Let's look at 8.
No, 7.
All right. There's a Monty Python joke in there somewhere, but I won't make it. All right. Number 7. We are told that we have a 45, 45, 90. A√2. Yes.
Mhm.
And what are we given? That B, well, B is A, so that these are,
No, C is 5.
no, you're just 7. So we know that that's 4√2. So we know that A is equal to 4√2. So all you have to do is plug in 4√2 times √2, which is 2 times, which is 8. There you go. If you get confused, I'll walk down there, I don't know, 10, 15 minutes. Make sure you look at the table and give it a shot. I do want your homework, yeah. And any questions?
None. I have no questions.
Okay, we'll close it right there then, Ben. We'll see you tomorrow.
Okay, good. Anna's also here, just so you know.
Oh, Anna, I'm sorry. I didn't ask you one question, Anna.
That's okay.
You got it?
Yeah.
All right, cool. Catch you guys later.
Goodbye. Have a nice day.
Bye.
Yep.
My imagination.
What?